The time, 2:47 local. The night is pitch black over the Black Sea. A Russian patrol boat's radar screen flickers, detecting the impossible. A fast-moving swarm of Ukrainian drones breaching the defenses of Crimea's most protected airspace. What happened next wasn't just a skirmish. It was a military system's worst nightmare. The drone operator's feed lights up 5 streaks of light. $30 million worth of state-of-the-art precision missiles fire into the void in blind desperation. The smoke clears, and the unthinkable is confirmed. The target is still flying, completely unharmed. A devastating reality check that exposed a fatal flaw in the entire Russian defense system. Their destination, the peaks of Mount Ai-Petri, home to the sprawling Russian defense network. On the beach below, the Pantsir S1 air defense system spins its radar in blind mechanical fury. This is not old Soviet junk. This is their premier point defense weapon, designed to shred cruise missiles and protect vital assets. It had just fired a king's ransom in ordnance and failed to scratch a drone that cost less than an iPhone. The Pantsir switches to its secondary defense. Cannons erupt, painting the sky with useless 30mm tracers. The Russian operator is baffled. His $100 million system has a fundamental blind spot he doesn't understand: the Doppler Notch. The Ukrainian drone is flying sideways perpendicular to the radar beam at a precise 50-meter altitude. Radars don't just see objects. They measure the rate of movement toward or away from them. By flying sideways, the drone's radial velocity drops close to zero. To the radar's computer, a target with zero radial velocity looks exactly like stationary ground clutter. The system filters it out, rendering the drone functionally invisible. To compound the crisis, radar waves bouncing off the sea create ghost images below each drone. The tracking computer tries to lock onto the average position between the real target and its reflection, sending multi-million-dollar missiles harmlessly into empty air. Those proximity fuses needed a target the size of a car door to trigger. These FPV drones gave back 1/100th of that return. They literally didn't register as a valid target. While the Pantsir operator struggled with his now useless paperweight, more drones appeared on the thermal feed, a swarm of mechanical wasps converging from every direction. The Pantsir had detected them at 2 kilometers, but its missiles need 1.5 kilometers just to arm. That meant 12 seconds from first detection to watching the targets fly past. 12 seconds to engage a target his system was never designed to see. Radio chatter exploded into panic. Controllers demanding fighter support. Someone yelling about missiles that wouldn't track. These were not the supersonic tomahawks they'd trained for. They were small, fast toys, and somehow that made them a ghost. At 0250 hours, the lead drone locks onto the first enormous dome. Inside that shell sits a radar worth hundreds of millions, capable of tracking ballistic missiles and providing early warning for the entire Black Sea. The domes were designed to survive 2,000-pound bombs. No one considered an attack from a consumer drone flying at treetop height. In a final desperate act, a Russian Su-30, their answer to the F-15, fresh from the production line, dives through the pre-dawn darkness. The pilot's advanced BARS radar starts showing gibberish. Contacts appear and vanish like fireflies, dropping below the noise floor, the baseline static of the environment. The system needed 5 consecutive returns to confirm a target. These drones kept dropping out after 2 or 3. The radar couldn't distinguish the faint signal from background static, forcing it to keep starting over, never establishing a track file. Frustrated, the pilot launches an R-73 missile, $20 million of precision engineering designed to chase jet fighters at Mach 2.5. The drone's camera catches the whole show. The missile races close, then veers off as if forgetting its purpose. The problem is temperature. The R-73 hunts for jet engines burning at 1,000 Celsius. The electric drone motor runs at a mere 50 Celsius. The missile's infrared seeker couldn't lock on until it was too close, and by then, it was moving too fast to correct course. The pilot fires a second missile, a near miss that shakes the drone's camera. Even pulling 40 Gs at Mach 2.5, the missile's turning radius is still 600 meters. When the target shifts randomly, physics dictates a miss. After $80 million in wasted ordnance, the pilot empties his final weapon, the GSH-30 cannon, spraying 30mm rounds at 1,500 per minute. Still nothing connects. More drones are now visible, not from Ukrainian territory, but materializing 10 kilometers off the coast like ghosts rising from the sea. The Russians missed what was under their nose. FPV drones sitting on launch rails 10 kilometers offshore, operated from Unmanned Surface Vessels, USVs, of the Ursula family, completely invisible to the mountain's radars. The secret wasn't technology, it was basic trigonometry. The Podliot K1 radar sits at 3,600 feet. but its design has a minimum depression angle of -2 degrees. This physical limitation carves a blind zone the size of a small city below 43 meters altitude within 10 kilometers of the shore. The USVs cruise at 5 meters, sailing unopposed through a physics-based loophole. Seeing the first S-400 radar destroyed, the USV launches its full swarm, their motors screaming like angry hornets. The FPV drones fly this far using the relay boat system. Ukraine doesn't fly drones directly. They use these USVs as floating cell towers, positioned offshore with powerful antennas. The operator's commands bounce from Odessa, through an encrypted Starlink link to the boat, and then instantly to the drone. This lets operators stay safe hundreds of kilometers away, flying a precision combat mission from what is essentially a floating Wi-Fi extender. As dawn approaches, more boats are revealed, each launching a new swarm that scatters like startled birds. The coastal radar should have seen the USVs, but they were programmed to ignore anything moving under 20 knots, filtering it as civilian traffic. The USVs deliberately cruised at 15 knots, invisible by choice. The second swarm hits the first dome's base, no doors, no windows. But the Ukrainians found what the designers missed: emergency access panels at ground level. The panels could withstand 500 psi of overpressure from bombs. They could not withstand the 2 million psi from a direct contact shaped charge. The Nebo Dome, Russia's crown jewel, the answer to stealth technology, supposedly capable of detecting F-35s at 600 kilometers, takes the next hit. Without it, every S-400 battery in Crimea goes blind past 40 kilometers. The Nebo's massive array takes hits that turn insulators into superconductors, sending 1,000 amp surges through delicate circuits. 40 seconds later, the Pantsir K1 is destroyed. This radar watched Crimea's low-altitude approaches. Years of coverage vanished in seconds. Below, a BK-16 landing craft appears, firing everything it has, but its navigation radar can't calculate a firing solution. The drone, dumb and determined, hits the bow. Back on the mountain, the cascade is complete. The S-400 batteries that everyone feared are now expensive lawn ornaments. They needed the Nebo and the Podliot for vision. Without them, their operators can only watch. The Ai-Petri command post, the brain of Western Crimea's air defense network, takes the final decisive hit. The shape charge turns the reinforced door into modern art. Fire erupts, and volatile secondary explosions confirm the command capability is gone forever. The entire chain of defense acquisition, fire control, and launch has been severed simultaneously. There are no backups within 100 kilometers. Bye for now. If you like deep dive in military, please don't forget, like, comment, share, and subscribe for more informative videos. Thanks for watching.